the last video we have observed, the last point was the difference between the ideal solution and the non-ideal solutions. Today, we are going to observe what will be the situation of Raoult's law in case of non-ideal solutions, whether the equations will remain the same or whether there will be any kind of deviations or not. See, if we are talking about a binary solution means two type of liquids are supposed to be taken. Suppose A and B, these are the two liquids. So before mixing between the molecules of A, there will be some kind of interaction, and between the molecules of B also there will be some kind of interaction. So after mixing, what will be the interaction between A and B, that will decide what will be the vapor pressure. That will decide means between A and B whether the interaction is more than previous or whether the interaction is less than the previous. Previous means between the pure liquids. So if we observe that the interaction is more between A and B, then what happens? The tendency to get vaporized, the tendency to escape will be lesser. And simultaneously, the opposite case can also happen. So here we are going to observe if the solution is non-ideal, then depending on the interaction between the two type of liquids, we are going to see the deviation from Raoult's law. So first we are going to express that mathematically. We will try to understand the explanation of it. Then we are going to plot it graphically. Let us see. So let us discuss the types of non-ideal solutions, and as an output of it, we will see the deviation from Raoult's law. So for that, as we were discussing, we have to consider a binary solution. And a binary solution means there will be two type of components, A and B. Now when A and B, both of them are mixed, then we will find the solution. So let us see the type of interactions that will be there. There will be A type interaction. There will be B type interaction. And after mixing of A and B, there will be AB type interaction. Now, when two liquids will form the solution, here we are talking about the liquid-liquid case, remember. When two liquids can form the solutions, A can also give rise to the vapor pressure, B can also give rise to the vapor pressure, and after mixing, the solution will also give rise to the vapor pressure. Now, we have to see what will be the total vapor pressure expected after mixing of it. Now, here we can see that if each components are having a partial vapor pressure, if the solution, the escaping tendency of the solution becomes more than the pure liquids, then what will happen? If the escaping tendency of solution, if it is greater than pure liquid, then what will be the situation? Then the solution will give rise to a larger vapor pressure compared to the pure solvent itself, means PA. After forming solutions, the vapor pressure given by A partial vapor pressure given by A will be higher than the partial vapor pressure of A when it was not mixed with B. Similarly, the partial vapor pressure of B after forming the solution will be greater than the partial vapor pressure of B when it was purely B only into XP. What we can already see, small deviation from Raoult's law. So P is equal to PA plus PB will always be greater than PA0 into XA plus PB0 into XP. In which case it can happen? Let us see the explanation. Let us see the explanation of it. Suppose we take two solutions. One is ethanol, say C2H5OH, and let us take cyclohexane, so C6H12. Now in normal ethanol, what happens? We can expect CH3, CH2, OH, and there can be another one, HO, C2H5. So between them there will be hydrogen bonds like this, H bonds. Now here we need to understand that when the ethanol is mixed with cyclohexane, then the molecules of cyclohexane, they tend to occupy the space between the ethyl alcohol molecules. So as a consequence, the hydrogen bond in alcohol molecule breaks. These bonds are going to be broken, and the attractive forces within the alcohols are weakened. In which case, when ethanol combines with cyclohexane, the cyclohexane molecule will occupy the spaces between the ethanols. So as a result, the attractive forces between the ethanol molecules will be weakened. So obviously, whatever the attraction it was, if it is broken, the tendency to escape will be greater. The attraction force between ethanol is not there anymore. So escaping tendency increases. If escaping tendency, if it increases, it directly gives rise to higher vapor pressure after forming the solution, remember. So in this case, the vapor pressure will always be greater than the expected one. So in this particular case, we can see that the total vapor pressure will be greater than what was expected. So we can call it the positive deviation from Raoult's law. So it is a first kind where we are observing the positive deviation. So we are observing the positive deviation. There will be another one where we will observe the opposite case, the negative deviation. So this is just the opposite case. So here also it's a binary solution. That means A and B, two liquids are taken. But here we will observe that the AB interaction is stronger than AA type or BB type. That means after mixing, the interaction becomes higher. So if the interaction becomes higher after forming the solution, obviously the escaping tendency will be less. So escaping tendency of solution will be less than that of pure liquids. So if the escaping tendency is less amount of vapors are going to be generated after forming the solution. So as a result of it, if we write down mathematically, we should be able to write that the PA means the vapor pressure of A after forming the solution is less than the vapor pressure of A when it was not mixed, and simultaneously PB should be lesser than PB0 into XP. So it is quite obvious that the total P, which is PA plus PB, should be always less than PA0 into XA plus PB0 into XP. And let us see some explanation for that. Explanation with examples. For this, we have chosen, there are various examples like acetone and chloroform and diethyl ether, chloroform and nitric acid, so and so. But let us choose a very simple case of acetone. This is the acetone molecule, and let us choose a chloroform. In chloroform, it is obviously polar, and between the chloroform also there can be hydrogen bonding. But what happens is, here delta plus delta minus, when these two are combined, the hydrogen bond that is formed on this region is strong enough. So as a result, when acetone combines with chloroform, the AB interaction is always greater than AA type or BB type. That means the interaction between the chloroform molecules or between the acetone molecules are going to be lesser compared to the fact when these two are combined, because of this strong hydrogen bonding between themselves. So if acetone and chloroform both are volatile, they are having the tendency to get escaped, but after combining with each other, the escaping tendency becomes less, and as a result of it, we are going to observe the negative deviation from Raoult's law. So let us see what is the outcome of this negative deviation. We will be observing that delta V, as a result of it, we will be observing delta V mixing is always going to be negative in this case. And in the previous case, we will observe that delta V mixing is always positive. So this is the outcome of the non-ideal solution having the positive and the negative deviation. Now let us see it graphically. So in this diagram, on the left hand side we can see the positive deviation from Raoult's law. You just rewind the video and see that in case of positive deviation, what we have observed is the PA is greater than the PA0 into XA and PB is greater than the PB0 into XP, and the total vapor pressure will always be greater. So see on the left hand side, the vapor pressure that is written by the blue lines are always greater than the expected one. Pressure that is written with the green dotted lines are the expected vapor pressure for the ideal solutions. So the non-ideal cases are plotted with the blue lines on the left hand side, and the ideal cases are plotted in the green lines. In the right hand side also, we can expect that if the association of the A and B is greater, so the escaping tendency will be lesser. So in that case, the PT will be less than PA0 into XA plus PB0 into XP, and as a result of it, if the escaping tendency is less, so on the right hand side you can see that the vapor pressure is lesser than what was expected, and the green lines were showing that the expected vapor pressure, which was the ideal case. So in the left hand side, in a nutshell, we can say that the vapor pressures are greater than expected, so it's a positive deviation. On the right hand side, we can see that the vapor pressure for the non-ideal solutions are less, so that is why the negative deviations are being observed. Students are requested to keep the video on the highest possible resolution and solve the problems which have been given over here on the related topic along with the NCERT problems. And if there is any particular numerical not being solved, you can directly ask the question to me in the given format by the school itself.